Good morning, my dear students. This is the part 3 of chapter 6, algebraic expressions and identities. Today's topic is multiplication of algebraic expressions. We shall study about the multiplication of monomial expressions. For multiplication, we shall follow some simple rules. Rule number 1, the product of two terms with like signs is positive and the product of two factors with unlike signs is negative. That is, product of two positive terms is a positive term. The product of two negative terms is also positive. The product of one positive term and one negative term will be a negative term. Rule number 2, if x is any variable and m and n are two positive integers, then x to the power m into x to the power n equal to x to the power m plus n. You have got this property in powers and exponents in chapter 3. So you can remember. I have shown it with example. Find the product of x to the power 3 and x to the power 2. Here base is same x and the powers are 3 and 2. Therefore, the product will be x to the power 3 plus 2, which is equal to x to the power 5. Another example, x to the power 4 into x to the power 5, it will give x to the power 4 plus 5 equal to x to the power 9. Rule number 3, while multiplying two monomials, the product of the numerical coefficient is multiplied with the product of variables. Check with the example. 3x into minus 4xy. I shall write the coefficients of the two terms separately. 3 into minus 4. Then I shall write the variables x into xy. The power of x is 1 for one term and the power of x for the other term is also 1 and the power of y is 1. So, it is equal to 3 into minus 4 is minus 12. X to the power, the sum of the powers, that is 1 plus 1, and y to the power 1, which is equal to minus 12x square y. Exercise 6.2, question number 1, find the product of the following pairs of monomials. It is very easy only. Minus 3x into 2x, the same way we have to do. Minus 3x into 2x, I shall separate the coefficient. Minus 3 into 2, then the variables x to the power 1 into x to the power 1, which will give minus 6x to the power 1 plus 1 is equal to minus 6x square. So question number 3, minus 7p comma 3p square q. I have to find the product of these two monomial terms. I have to write the coefficient and the variables separately. So it will be like minus 7 into 3 into p to the power 1 into p to the power 2 into q, which is equal to minus 21 p to the power 1 plus 2 into q equal to minus 21 p to the power 3 q. Question number 2. Find the area of rectangles with the following pairs of monomial as their length and breadth respectively. So, question number 3 I have taken for explanation. 6m square n square p 2m n p square. So, I have taken the first term 6m square n square p as length and the second term 2m and p square as breadth. All of us know that area of a rectangle is length into breadth. Therefore, the area is equal to 6m square n square p into 2m and p square. Writing the coefficient and variables separately, 6 into 2 into m square n square p into m and p square. The power of m and n is 1 in the second term and power of p is 1 in the first term, which will be equal to 6 into 2 m to the power 2 plus 1 n to the power 2 plus 1 p to the power 1 plus 2 equal to 12 m cube n cube p cube. Question number 3. Find the product of a square b minus 2 a cube b and ab. Here the coefficient of a square b and ab is 1. So I can write it as 1 a square b into minus 2 a cube b square into 1 ab. I have written the same variables together. So it will be like 1 into minus 2 into 1 a square into a cube into a into b square into b, which will be equal to minus 2 a to the power 2 plus 3 plus 1 b to the power 1 plus 2 plus 1 equal to minus 2 a to the power 6 b to the power 4. Again I have shown one example. Question number 5. Find the product of 2xy square, 3x square z and xyz. So it will be 2xy square into 3x square z into xyz equal to 2xy square into 3x square z into xyz. So again separating the coefficient and the variables, 2 into 3 into 1 x to the power 1 y square into x square z to the power 1 into x to the power 1 y to the power 1 z to the power 1 equal to 6 x to the power 1 plus 2 plus 1 y to the power 2 plus 1 z to the power 1 plus 1 equal to 6x to the power 4 y to the power 3 z to the power 2. So classwork you do from exercise 6.2, question number 1, 2, 3 and 6. Homework you do question number 2, 5 and 6, question number 3, 2 and 4. This is all for today's class. Have a great day.